For thousands of years, humans noticed a strange light appearing briefly near the horizon just before sunrise or after sunset. Ancient civilizations believed it was two separate stars, one appearing in the morning sky and another in the evening. But both were the same object, a small world orbiting closer to the Sun than any other planet. That world is Mercury, the first planet of our solar system, and one of the most extreme worlds ever discovered. At first glance, Mercury appears simple, a small gray planet covered in impact craters, often compared to Earth's moon. But beneath that surface lies a world filled with scientific mysteries. A planet containing frozen water near the hottest region of the solar system. A planet slowly shrinking as its massive iron core cools. And the very planet that helped confirm Albert Einstein's theory of general relativity. Mercury orbits the Sun at an average distance of only 58 million kilometers. The sunlight there is nearly 7 times stronger than on Earth. During daytime, surface temperatures can rise above 430 degrees Celsius, hot enough to melt lead. But because Mercury has almost no atmosphere to retain heat, temperatures collapse after sunset. At night, they can fall below -180 degrees Celsius. This gives Mercury one of the most extreme temperature ranges in the entire solar system. Surprisingly, Mercury is not the hottest planet. That title belongs to Venus. Venus remains hotter because its thick atmosphere traps heat continuously. Mercury's atmosphere is so thin that scientists classify it as an exosphere rather than a true atmosphere. Atoms on the surface are constantly stripped away by solar radiation and powerful solar winds. Although Mercury is the smallest major planet in the solar system, it contains an enormous metallic core. Nearly 85% of the planet's radius is dominated by iron. Scientists believe Mercury may once have been much larger. A colossal impact early in the solar system's history could have stripped away much of its outer rock, leaving behind the oversized metallic interior seen today. In a sense, Mercury may be the exposed core of an ancient planet. Even more remarkable, part of that core remains molten. Mercury is still cooling internally, and as the core contracts, the planet slowly shrinks with it. This process has created enormous cliffs and fractures across the surface called scarps. Some stretch for hundreds of kilometers. Mercury is the only known planet where scientists have directly observed evidence of global contraction on this scale. One of Mercury's most surprising discoveries is the presence of frozen water. Despite being the closest planet to the Sun, Mercury contains ice deposits near its poles. This is possible because the planet has almost no axial tilt. Some deep polar craters never receive sunlight. Their floors remain in permanent darkness, where temperatures stay extremely low for billions of years. NASA's Messenger spacecraft confirmed that these shadowed craters contain significant amounts of water ice. It was a discovery that changed scientific understanding of the inner solar system. A planet exposed to intense solar radiation still managed to preserve frozen water in regions untouched by sunlight. Mercury also played a major role in modern physics. Astronomers discovered that the planet's orbit behaved slightly differently than predicted by Newton's laws of gravity. The difference was extremely small, but it could not be explained. For years, scientists searched for answers. Some even proposed the existence of another unseen planet near the Sun. The mystery remained unsolved until 1915. When Albert Einstein introduced general relativity, Einstein proposed that gravity is caused by the bending of space-time itself. Because Mercury orbits so close to the Sun, it moves through one of the most intense gravitational regions in the solar system. When Einstein applied his equations, Mercury's strange orbital behavior matched perfectly. The planet became one of the first major confirmations that general relativity was correct. Mercury experiences one of the strangest day-night cycles in the solar system. The planet rotates very slowly while orbiting the Sun extremely quickly. As a result, one full sunrise to sunrise cycle on Mercury lasts 176 Earth days, longer than Mercury's entire year. In some regions of the surface, the Sun would even appear to stop moving across the sky temporarily before reversing direction and continuing again. No other planet experiences this exact phenomenon. Despite being the closest planet to the Sun, Mercury is one of the most difficult worlds for spacecraft to reach. Traveling toward the Sun requires enormous amounts of energy. Because spacecraft must reduce much of their orbital speed around the Sun. NASA's Messenger mission spent nearly 7 years traveling before finally entering Mercury's orbit in 2011. Today, the joint European and Japanese mission Bepi Colombo is continuing the exploration of the planet. Scientists hope it will reveal more about Mercury's formation, magnetic field, and unusual interior structure. Mercury rarely receives the same attention as planets like Mars or Saturn. It has no giant rings, massive storms, or thick atmosphere. Yet Mercury remains one of the most scientifically important planets in the solar system. This small world preserves evidence from the violent early history of planetary formation. It revealed flaws in Newton's understanding of gravity. It contains frozen water in permanent darkness beside the Sun. And beneath its heavily cratered surface lies an enormous metallic core, unlike any other terrestrial planet. Mercury may appear quiet and lifeless from a distance, but it helped humanity understand both the origins of planets and the nature of space-time itself.